Hey class, let's quickly work through this same problem that they just did on Khan Academy, Sal just taught us, in Excel. So here's our two data sets that he gave us. Data set 1, data set 2. So quickly let's, actually I wanted to show you something. This is kind of sometimes handy. We're going to take an average and a range and all these things of each of these data sets, right? So we can actually name these data sets. Instead of referring to them to their cell reference, we can actually give them a name, any name we want, really. So how do you do that? Well, it's pretty simple. You just have to highlight the data you want. So I'm going to go up to the top, Control-Shift down, and then if I go over here to this little box right here, this is called the name box. Right, so I can actually click in there and type whatever I want in here. So I could call this, let's call this data underscore 1. Right. So now what that means is, if I click on this little arrow and click on data 1, it highlights that. Right, so I can do the same thing over here. If I highlight data set 2, go in here, type in data. What did I call it before? I've forgotten already. Set 2 underscore 2. I think I've called those two different things. So data 1 and set 2. Great. So anyway, now I have these two names. Set 2, there's set 2, and then here's data 1. And then when I go to type the average, I can say equals average. Instead of going up here and highlighting the data, which isn't that hard, I can, well, there it goes, it just types. I can type in data 1, right? So as I start typing it, you can see I get this little guy that pops up. I can hit the tab button and say, yeah, that's what I want. And then look, it actually highlights it all. So that's pretty cool. The problem with this, not really a problem, but it kind of takes away some of the functionality that's cool in Excel. Like, so I say Control and paste this. So if I put in just the numbers, and if I pasted this over, it would have pasted, it would have sort of moved over, right? It would have just taken that, that cell reference and moved it over. If I had used the cell references as opposed to a name, instead it doesn't do that. I can't figure that out. You want to do that, so you have to go in here and change this. We call it set to. Right? So anyway, in this case, it might not actually be that handy to do what I just did, to do this naming thing. But it, sometimes it comes in handy. If you have a specific cell, you can name just one cell, right? Or what I did is name a range of cells. So either way, it comes in handy. So that's an aside. It's sort of an Excel trick. So actually, I'm going to go in and change that. So one way, once you decide if you want to change some of these names, click on Formulas and go to Name Manager. And here's data 1, here's data 2. You can change the values in here. I'm going to go ahead and just delete them. I don't really care. After I looked at it, I decided it's not such the best thing to do at this point, but now we've learned how to do it. Okay, so then let's see what happens. It doesn't know what data 1 is anymore because I've deleted that. So that's okay. So I'm going to highlight this guy. F2. Control Shift up. Let go of the control button. Hold the Shift button down. And I just want that name. Right? So now I can say Control Copy, Control Paste. All right, so there's our averages, just like Sal told us. We only have 10, or the average of 10 for both of these data sets. So the range actually is not a range statement, right? So if I type equal range, nothing comes up, right? Yeah, if I try to do something in here, watch, it's gonna be like, nah, name. I don't know what range is. There's no such thing as a range function in Excel. So how do we do this? Well, there's a max function. Right, so we can find the maximum of all those. And then the range is just the max minus the min, but also the min function. So that's how we do. Just find the max, subtract it from the min. Right, so the max of this range minus the min of the same range. Hit enter. Now I say Control Copy, Control C, Control V, and we can see the range of data set 2 is much smaller, so 40 and 4. All right, so the variance of the population. So this is what Sal did, variance of the population, and then he showed us the standard deviation of the population. We're going to kind of go in and do a little bit more variance of a sample as well as standard deviation of a sample. So these are just slightly different, and there's functions specific for each of these in Excel. But I wanted to actually walk you through one of these. He walks you through specifically how to do each of these, but let's just do one, how to calculate this if you had to. So first of all, let's just do it with the Excel function. So if I start typing in variance, VAR, the function is var. So I'm using Excel 2010, And in 2010, Excel started introducing these dot functions. So there's var.p, which is the variance of a population. In older versions, it's just var.p, no dot, right? So in 2010, you're allowed to use either one. You can use var.p or var.p, doesn't matter. So I think most of you now have 2010. You know, whatever one you want to use, you want to be more comfortable with. The word from Microsoft is they're going to slowly phase out the older, like the var.p, and just it'll make you keep the var.p, but my guess is that's not going to happen for a long time. So anyway, you can use either one in 2010, right? So it doesn't matter if you have 2010 that you have to use the .p or .s. So .p means I want the variance of the population, so let's just use that one. So I hit Tab, use my arrow keys up here, Control-Shift-Up, I'll go with the Control, push my arrow key down 1, now I have that set. Variance of the population is 200, Control-Copy, Control-V, it's only 2 there. All right, so let's actually walk through what's going on here. I'm going to insert a couple columns in here. So Sal talks about what this formula looks like. In fact, let me write it out real fast. Let's do this. Review. Start. Okay. So the equation for a variance of a population is pretty simple. So let's just write over here. This is a variance. Of the population. It looks something like this. So we have a summation sign, and so we're going to sum a whole bunch of stuff. And what it's going to be is sort of this x bar, right? X bar. Actually, this is a whole population. It wouldn't be x bar. It would be mu, which is just the same the population mean. Oops. So let's fix that. So this is going to be where we go? Mu minus each of our xi's, and we're going to square that guy, and then we're going to take that and divide it by n, big N. All right, so big N is what is just the count of our total population. So this mu guy is just the mean, which we've already calculated right here, 10. All right, we give it a different name if we're talking about a sample. We call it x bar. That's okay. And then these xi's. So xi's are just each individual observation. So this is x1, x2, x3, x4, x5. We call those xi's. Right, xi's. And we square those. So this is this guy on the top is just the difference of each of these from the mean. We call that the deviation from the mean. Right. So let's actually type that. Little dot here. All right, so we'll call this the deviation. Deviation from the mean. And how do you do this? Well, so we just take our average, right? And I'm gonna lock that in F4, and from that subtract each xi. Right. So there's the first one, and now I can just use my little trick and copy that down. Right. So here's all of them. So that's just this part. Mu is the mu minus xi's, right? Then we have to square those guys. All right, so then we just call this is the square deviation. Deviation. So this number squared, so I just do the caret 2. All right, then I can just do that for all of those. So now I have done that for all of these. The next step is the summation sign, right? So this is sort of towards the end, right? So once I do these individually, then I can sum those all up. So I can use this auto sum function, right, which is alt equal. Alt equal just sums whatever's above it or to the left, right? So there's 1,000. And then I'm going to divide by big N. So what's big N in this case? So big N is 5, right? The reason I know that is because there's only 5 members of my population. 1, 2, 3, 4, 5. Right? So then I just say, here's actually my answer. This 1,000 divided by 5. There it is, 200. All right, so there's the answer with the easy one, var.p. Here's how we got to the answer, is this function right here. All right, so the only difference between the variance of the population and the variance of a sample is that we're now going to use, instead of essentially this n, so let's start this right here, sample. It's going to look a little bit different. Let's see if I can scroll down. can look like this. So we're going to say I have summation of, instead of a mu, we're going to call it x bar, but it's the same thing, right? X sub I squared divided by, instead of big N, we have a little n, right? Because then we're talking about samples. This is just sort of semantics. But the one thing that's a little different is that we subtract 1 from that. And the reason why is because when we're dealing with samples is we're actually estimating something about a population, which we're going to predict something about a population. And every time we do that, we lose what we call a degree of freedom, which means that once we sort of estimate one thing, if we use that same thing to estimate something else, we can't be as exact. So this formula has this x bar, which is an estimate, right? This is, we actually go ahead and estimated this. And since we've estimated this for a sample, then we can't estimate this, this new variance without losing a degree of freedom. So we're subtracting 1 from that. So that's the only thing. So we could go through this whole sort of rigmarole. Actually, everything is exactly the same, except for the very end, right? So let me show you what I mean here. The only difference is instead of dividing it by 5, right, we're going to now divide it by what? N minus 1, 4. That's the only difference, right? So we have this 1,000 divided by 4, essentially. This would be 250. So now, let's see if that's right. So we can do this equals var.s, or in the older version, it's just var. Right? So var.s and var are the same, so it doesn't matter which one you use. Let's highlight this data. 250. All right. So there we go. So that's the only difference between the variance of the population and the variance of the sample. All right. So let's. I'm going to actually highlight those and right-click, and say, I'm going to say hide. Yeah, so they're actually still there. So it goes BDE. We can unhide them later, but we don't really care to look at them right now. Okay, so let's copy this guy and paste it over. All right. So there's our variance. So standard deviation. So the last thing. So back to our formulas over here. So because we're squaring things over here, this idea of a variance is actually pretty hard to explain, like what a variance is. So instead, because it's a squared deviation from a mean, an average squared deviation from a mean. So that doesn't make a whole lot of sense, but since we square it, the standard deviation just takes the square root of all of this and gets it back into the original data, essentially, like the scale of the original data, or something that we can compare to an original data. So that's easy. So all I do is just like square root of variance of a population. Right, so that'll give us the answer 14.14. Or we can just type in standard deviation, standdev.p, or standdev.p. There it is, standdev.p. And then do this, right? Either one. And standard deviation of the sample is just equals standard dev sample.s, or just standdev. Right? That's the old version. There you have it. So our standard deviation is 14.14 if it was a population, or 15.8 if it was a sample. So the reason I did this both ways is just so we get some practice. We don't know if this is a sample or if it's a population. In this class, most of the time we're going to be dealing with samples, right, going forward. So, but more and more we're getting sort of complete population data as we have these data sets that actually capture everything that happens. Then we can sort of deal with more of these populations. But realistically, it doesn't really matter once your sample size gets really big, right? So if my n here is, say, 1 million, and my n minus 1 is, what, 1 million minus 1, these two numbers are practically the same, right? There's not a whole lot of difference. So it doesn't make a whole lot of difference when n gets really big. But in this case, n was pretty small, and so it did make a pretty big difference. All right, that's all for this video.